Okay, so now that we're through our different minerals, we can take a look at rocks. So remember, rocks are just when minerals get together and have a party. Rocks can be composed of just one mineral type or a bunch of different mineral types. As we've talked about, there are three main categories of rocks. Igneous, which remember form from molten rock, right, whether it's lava or magma. Sedimentary, which are the ones that we are most concerned with, that mostly form from the erosion of other rocks, or metamorphic, and those are rocks that change with heat and pressure. The important thing I want you to note is that all three of these rock types are interconnected through what we call the rock cycle. So if we start, let's say, with a magma, right? That magma comes to the surface maybe through a volcano, and we have a lava flow. Well, that lava flow, right, that's our igneous. And that lava flow, now that it's cooled and exposed to the air, you can see it's going to start raining on it, and the wind's going to whip across it, and it's going to start to erode, break down into small pieces. Those small pieces are going to get transported somewhere, maybe by a river flowing across it or a stream. It might bring it to a lake or out to an ocean. That then becomes sedimentary rock, right, that gets laid down. Over time, that sedimentary rock may get buried, and as it gets buried, it starts to experience higher pressures and temperatures, and those pressures and temperatures turn it into a metamorphic rock. If it continues to get buried, it's going to remelt and form another magma. So as you can see, all three of these rock types are interconnected. You really can't have one without the other. And like I said, all three of these rock types are interesting. However, we're really only going to concentrate on the sedimentary rocks. So let's take a look very briefly at our sedimentary rocks because we're going to investigate this further when we get into Chapter 5. So our sedimentary rocks are composed of sediment, which is loose particles. Again, I want you to think of beach sand, right? That is really the best example because I know you've all seen beach sand. That's sediment, loose particles. Over time, that sediment can become rock through the process of lithification, which we're going to talk a little bit more about in Chapter 5, but it's through compaction and cementation, compacting those grains together, and then they basically get glued together. Now, there's three main types of sedimentary rocks, and so this is just going to be a very brief introduction because we're going to get much more into these in Chapter 5. We have our clastic rocks, which I really want you to remember this word because we're going to see this word come up again in Chapter 10, and I'm going to ask how many of you remember what that word means. So this is an important word I want you to remember. Clastic rocks are rocks that form from the erosion of other rocks. So sandstone, for example, right? Sand forms from the eroded particles, right? So at the beach, right, all of that material is supplied from wherever the river that brought that sand in, right, is eroding out of. So when you pick up a handful of sand, say down here on the Mississippi Delta, you might be holding 30 states in your hand, quite literally. We're going to see that all of these different categories, these four different categories of sedimentary rocks, are going to be broken down by grain size, from the largest to the smallest. Our next group is our chemical or biochemical. So either they're forming from chemical means or from organic means, right? Hence the word bio there. The three most common ones that we're going to talk about are evaporites, right? Those that form from evaporation. Carbonates, right, which we just talked about a moment ago, and that's definitely a biochemical rock. And then we're also going to talk about silica sedimentary rocks. And then our third category is the organic sedimentary rocks, and really the only rock that fits into that category is coal. So let's just take a brief overlook here. So I want to talk about our clastic. Okay. So remember, clastic rocks, like I said, are rocks that form from the erosion of other rocks. So we have to ask ourselves, well, what is the most common rock that we find on the continent? Well, the continent is mostly composed of granite, right? That is by far the most common rock. If we take a look at granite, there are four major components of granite. We have ferromagnesian minerals, which that word looks complicated, but ferro is iron, magnesium is magnesium. So these are any mineral that may have iron and magnesium in it. Then we have plagioclase and orthoclase, which if you remember, those are both feldspars, and then quartz. Now, what's interesting is the feldspars and the ferromagnesium minerals, what happens is over time as they get eroded, right, the rain beats down on it, the snow goes on it, the ice moves across it, the wind whips across it, both of those, the ferromagnesium and the feldspars, turn into clay over time. They undergo hydrolysis, which means that basically the chemical structure starts breaking down and it starts falling apart and it turns into clay. However, the most important mineral here is quartz. Quartz doesn't change. All that will happen to that mineral is it will break down into smaller and smaller particles. It will not undergo hydrolysis. If you remember, quartz has a hardness of 7. So it is of 6. So it is a very, very strong mineral. So it will not break apart, which is why we find it mostly in sandstone. So what we can actually tell, and we're going to talk about this more in the next chapter, is what we call the maturity of our rocks based on the quartz content. Right? We can tell how long it's been in the system. So again, our clastic rocks, remember I told you we break them down by grain size from the largest to the smallest. There are 3 major components of all of our clastic rocks. We have the clast, which is our larger pieces, right? So again, if you think of sandstone or gravel, here if you look at this picture, that's the big pieces. Matrix, that's the fine grained material, which is usually mud that surrounds the big grains. And then cement, which is what you can't see. Okay, that's a chemical structure there that's holding it all together, acting like glue. The most common glues are calcite, iron, and silica. So we'll start with our largest grain size, and that would be gravel. Right, so gravel is technically any grain that is larger than 2 millimeters, and we break our gravels down into 2 different types. If we see rounded grains, right, meaning, right, if I look at this, right, these look pretty round, okay, we call it conglomerate. If I look at my grains and my grains are really angular, that tells me, right, well, that's what we call a breccia. Now you might say, well, why would we make the distinction between the two? Well, it tells us how far, how close we are to where that rock initially formed, where those grains initially eroded out from. So again, I want you to think, let's say I had a rock in my backyard and I was letting it fall apart from the rain. As that rock falls apart, is it going to fall apart with nice rounded grains, or is it going to fall apart with big angular grains at first? Right? Well, it's going to fall apart with big angular grains. Over time, those angular grains are going to work their way, say, into a stream or into a river, and as they float downstream or downriver, they're going to start hitting the sides of the river and other grains and all that stuff, and those highly angular edges are going to become rounded over time. So if I see a breccia, it's telling me I'm very close to the source. However, if I see a conglomerate, it's telling me I'm very far away from the source. Our next grain size is sand, and we're going to talk about lots of different sand types in our next chapter. Technically, it's 1/16 to 2 millimeters in size, but the important thing is that it's visible, right? If you pick up a handful of sand at the beach, you can see all the individual grains. Now, silt and clay, our last 2 grain sizes, they're too small to be seen, right? You cannot see them with the naked eye. So the best way to tell these 2 grain sizes apart from each other is, in all honesty, to lick the grains. If you lick the rock and it feels a little gritty in your teeth, it's silt size. If you lick it and you don't feel any grit, that means that the particles are too small, and that's what we call clay. We're going to talk more about these individual different rock types when we get to the next chapter. Our next category is our chemical and biochemical. Right, as I said, there's 3 main ones that we're going to see here. The first one is our evaporites. And like I said, this forms from the evaporation of water. The most common, like I said, of all of our evaporite minerals is salt. That is by far the most common one we see. But we can also see gypsum and travertine. Travertine's an interesting one because this one actually forms in caves. The next one, like I said, is also a very important category, and these are our carbonates. So carbonates can either form through chemical or biochemical through the process of organisms, different processes. Remember, our three different minerals that we tend to see are calcite, aragonite, and dolomite. And here's our most common carbonates. There's a whole bunch of other ones, but the ones we're going to run across in class, micrite. This is more like a very fine-grained mud. Okay, this is not usually a biochemical process. This is usually a chemical process. However, these other ones down here, these are all biochemical. Ululitic limestone, that's this one, that's just a fun word to say. This is when we have little blocks of calcite that gets broken up by wave action, and it starts to roll around and kind of form particles the size of grains of sand. But you can see they're perfectly round like little BBs. Fossiliferous limestone, well, that contains fossils, so definitely biochemical. Coquina, this is something we see in our state specifically a lot. Coquina is a rock that is made up of broken shells that is glued together by calcite, and that's what makes it a carbonate. If you go out to western Louisiana and you go out to the beach, you would notice that there's no sand on the beach. It's actually all broken shells. That would be the coquina. Chalk is also a carbonate, the chalk that you write with on the chalkboard. It's made of these microscopic organisms called coccolithophores. We're going to talk more about those, especially when we get to the Cretaceous in age. We're going to talk about those. So let's take a look at our next group, and those are our siliceous rocks. So obviously these are rocks that contain a lot of silica. So they have silica and oxygen in them. The two most common ones are diatomite. You may have heard this before. It's called diatomaceous earth. It's like a clay, or it looks like chalk, but it's a little bit more slippery if you were to touch it. Diatomaceous earth is actually a fantastic rock because this is a rock that you can use to help keep out things like cockroaches in your house. It's made up of diatoms. If you've ever taken a biology class, you may have heard of them. They're these microscopic organisms, and their shell is made of silica, so it's basically made of glass. And they're microscopic, so they're tiny. But if you spread diatomaceous earth around, say, your door, what's interesting is those little tiny shards of glass, if you've got little tiny legs like a cockroach, you can't walk across it because it hurts. Those are tiny shards of glass. So that's a great way to keep those out. So see, geology can be useful. The other most common siliceous rock that we're going to see is chert, and chert is just microcrystalline quartz. It's not very exciting there. And our last group of sedimentary rocks is our coals. These are all organic. So coal is formed where plant matter can collect and compact over time. So the most common environment that we see coal forming in is going to be the swamp. Swamps don't have a lot of water movement, and because they don't have a lot of water movement, that means the water tends to be very anoxic, meaning it doesn't have a lot of oxygen. That lack of oxygen means that the plants don't really break down over time, so it just gets compacted. A loosely compacted coal is what we call a peat. You may have heard of this before if you ever garden. You tend to lay down peat because it's high in organics. If we take peat and compact it a little bit further, it's going to form lignite. Lignite is one coal that we burn for fuel. If we take that lignite and continue to compact it, we're going to form bituminous coal. And if we continue to compact it, we actually move over into a metamorphic rock, and that's what we call anthracosite. So those are our main types of sedimentary rocks. And like I said, in the next chapter, we are definitely going to go through these in a lot more detail.